Chemical reactions. There are 4 kinds of chemical reactions. We will start by discussing single replacement. Di-iron trioxide as a solid plus 2 atoms of aluminum as a solid combine to create 2 atoms of liquid iron plus di-aluminum trioxide as a solid. This is a single replacement because in the end we have an element and a new compound. You can see how the oxygen went from the di-iron trioxide to the di-aluminum trioxide. Single replacement. Double replacement. We start with dihydrogen sulfate, aqueous, plus 2 atoms of potassium hydrate, aqueous also, and they combine to become 2 atoms of hydrogen hydride as a liquid plus dipotassium sulfate, aqueous. This is double replacement because in the end we have 2 new compounds. Composition. Composition builds a new compound. We start with dinitride as a gas plus 3 atoms of magnesium as a solid, and they combine to become trimagnesium dinitride as a solid. As you can see, it went from 2 individual elements to a new compound. This is composition. Decomposition. Decomposition breaks things down. We start with 2 atoms of mercury oxide as a solid, and with heat, it breaks down to 2 atoms of mercury as a liquid plus oxide as a gas. You can see how it went from a compound combined with the heat represented as the Greek letter delta to 2 elements, breaking it down in decomposition. This has been chemical reactions.
Hello, this is a video about chemical and physical changes. Alrighty, now I'm going to go through a few problems and we're going to decide whether they are physical or chemical changes. P stands for physical and C stands for chemical. Now, a physical change is whenever something changes form or something like that, but it still has the same basic substance. So, a chemical change is whenever a substance changes completely, as in electrons and everything, and it forms a different substance. Alrighty. The first question is grinding chalk into powder. Okay, that would be a physical change. Even if the chalk is a powder, it is still chalk. It's just a different form, but the same substance. It's not orange juice, it's not toothpaste, it's chalk. Alrighty, melting of an ice cube. That again would be physical. That's because it is still H2O and it hasn't changed any electrons, it just changed form. Alrighty, striking of a match which burst into flames. Alrighty, this one would be a chemical change. This is a chemical change because it is no longer just like wood. Like the flame itself is a different substance entirely, formed out of different things like oxygen and everything like that. Alrighty, stirring orange powder into water until it dissolves. Alrighty, that's a physical change because even though it's mixed in with the water, it's still an orange powder. And it's still in there. Yes, it'd be very hard to extract, but it hasn't changed molecules. Alrighty, formation of a green substance on a copper water pipe. This would be chemical. The green substance is not copper, and it has just completely changed electrons and everything. Tarnishing of a silver teapot. Alrighty, this would also be chemical. That is no longer just silver. It is a totally new substance that has just changed. Alrighty, it hasn't changed form, it's just a new substance. This has been chemical and physical changes.
Balanced chemical equations are how you have to have each atom accounted for on both sides of an equation. Let's do some example problems. Iron metal reacts with aqueous copper 2 sulfate to produce copper metal and aqueous iron sulfate. Fe is iron, and it's a reactant. And we write S because metal is a solid. Cu is copper, SO4 sulfate, and that symbol means it's aqueous. Produces the product Cu, copper, and the S symbol means it's a solid because metal is a solid, plus FeSO4, aqueous. And as you can see, there is one of every atom except oxygen, of which there are 4 on both sides. So this equation is balanced. Aqueous hydrogen chloride combines with aqueous barium hydroxide to produce aqueous barium chloride in liquid water. So 2H2Cl, there are 2 hydrogen atoms because it's diatomic, so it always travels together. And the AQ symbol means it's aqueous. Barium hydroxide. And because hydroxide is an ionic compound, it is in parentheses, and it's aqueous. These reactants produce barium chloride, and that is aqueous. And liquid water. And it forms 2 molecules of water because hydrogen and oxygen are both diatomic. And because there are therefore 2 hydrogen atoms and the subscript is 2, so that's 4 hydrogen atoms and 2 oxygen atoms. So here to this hydrogen we have to put a 2 in front of it, so that there will be 4 hydrogen atoms on both sides. And this also makes it so that there are 2 chlorine atoms on the reactant side to match the 2 chlorine atoms on the product side. And as for the 2 oxygen atoms in the product, there are 2 of them in the hydroxide. Yeah. Solid silver oxide decomposes with heat into silver metal and oxygen. On the reactant side, it's the compound silver oxide. The S, of course, signifies that it's a solid. And there are 2 molecules of silver. And the 2 that doubles silver and oxygen on this side relate back to on the reactant side because there are 2 oxygen molecules when oxygen is by itself because it's diatomic. And the G signifies that it's a gas. And because there were 2 molecules of silver to begin with, signified by the subscript 2, and the 2 in front of the compound to produce 2 oxygen molecules produces 4 silver molecules, we put a 4 in the product side to signify that there are still 4 molecules of silver. And to signify that it decomposed with heat, we use the delta symbol. Yes. And that's how you balance chemical equations.